Okay, we're back, guys. So this video will cover from pages 6, I believe. Let's check. Yeah, 6 all the way to the end. All right, so two things here. The first is what's a reference angle? And then the second is how do we draw angles on the coordinate axes? So the convention is for an angle to start at 0 degrees along the positive x-axis and to rotate in a counterclockwise direction. All right, so 150 degrees, that's going to be somewhere here. I'm just going to call that 150. That's in quadrant 2. And now the reference angle is the angle between where your angle terminates, so the terminal angle, and the x-axis. And it's actually the, let me be a little bit careful, it's the smallest angle. Okay, so this is the smallest angle between terminal angle, where the angle ends, and the x-axis. All right, so this reference angle will always be less than or equal to 90 degrees, and it's going to be greater than or equal to 0 degrees. All right, I don't like how I did that. Let's just stick with this is between 0 and 90 degrees. All right, so the reference angle here, we just have to label it. We don't have to draw it or get a number for it. So that's the reference angle. 235, and actually I think what I'm going to do is go through all of these, the angles themselves first, and then the reference angles. So 235, well, that's somewhere here. That's 180 plus 45. 405, that's 360 plus 45, so that's somewhere here. This is 235, and maybe for this 405, maybe I want to indicate I've gone around once, and a little bit more. Okay? Negative 110, so if the angle is negative, it actually rotates in a clockwise direction. So that's going to be here, somewhere in there, negative 110 degrees. And 1260, well, that's 1080 plus 180. And 1080 is 3 full cycles. So if I go 1, 2, 3, and then another 180, that right there is 1260. Wow, that's a lot of rotation. And negative 45 degrees is right here. Negative 45 degrees. All right, let's label the reference angles. So keep doing that. The color is here. So reference angle for B is here. Reference angle for 405 is here. Reference angle for negative 110 is here. The reference angle for 1260 is actually just 0. It's right there. And the reference angle for this negative 45 is there. Yeah, that's it for that page. This one I'm going to skip because we're doing unit circle in lesson 2, so that's easy page. All right, radians. So radians, you have this sentence here that says if an arc is a length of 1 radius, then theta, our angle, has a measure of 1 radian. So what that's really saying is, if you look at this picture, right, this is some general circle. There's a radius here, a radius here. There's also an arc length, right? So we could measure the length of this arc. If that arc is r, right, and this radius is r, then all three of these lengths are the same. All right, the radius, the arc length. So the angle that produces that makes that happen is 1 radian. All right, kind of cool. So we can say that 1 radian, and by the way, this unit, or this measure is unitless, right? Radians are unitless. So 1 radian is an angle in a circle, and I guess I should say a central angle, right? A central angle that produces an arc with same length as radius of the circle. Okay, and I guess if you really want to compute it out, you could set up proportions. Okay, I'm not going to do that, but really nice, really nice and cool definition, right? What is 1 radian? All right, so it's an angle that produces an arc length with the same length as the radius of the circle. This vocab here, initial ray, that's just where you're starting, right? Where your angle is starting, so that in this case is here. The terminal ray is a ray that goes from the center of the circle out, tells you where to stop, right? So the initial and the terminal ray create this arc length. Standard position means you're starting with your initial ray right on the x-axis, okay? And you rotate counterclockwise. So standard position, this is 0 degrees, and positive is counterclockwise. And the reference angle we talked about before. Let's see, what else is here? Unit circle. Yeah, that has the center of the origin, so that's the point 0, 0. And the radius is 1 unit, that's really important. So the radius of this is 1. So this is the point 1, 0. And coterminal angles, they have the same terminal ray, right? Or in other words, angles that end in the same spot. And then I'm going to put assuming start standard position. Okay, so one example of that would be 0 degrees and 360 degrees, right? Both of those angles end right here. All right. Next page, how to convert between degrees and radians. So basically what we're going to do is multiply by a form of 1, right? So pi radians is equal to 180 degrees. Well, how do we show that? Well, if I have a circle, right, the total circumference of the circle is 2 pi r, right? That's how long it takes me to travel around the whole circle, right? If my radius is 1, then this whole distance is 2 pi. And if the whole distance is 2 pi, well, that means the angle that I rotate around in terms of radians is 2 pi. Okay, and that is the same thing as 360 degrees. So if we're saying these two are the same, then we can say that pi radians is 180 degrees. So in both of these ratios, what you're really doing is you're multiplying by a form of 1. Okay, pi radians and 180 degrees are the same exact thing. Okay, if I start with degrees and I multiply by pi over 180, well, the degrees here and the degrees here are going to cancel out, and I'm going to end up with an answer in radians. If I start with radians here and I multiply by 180 degrees over pi radians, well, these radians and these radians, well, they're unitless, so it doesn't matter, but you could think of them as canceling, and then this 180 degrees, that's what the units of your final answer will be in. All right, so you've got two examples here. I'm going to stop, have you work through those, and then when you've got an answer, you can start the video again and see if we agree. All right, if you want to pause it, do so now. Okay, so to go from 80 degrees to radians, I'm going to take 80, and I'm going to multiply by pi over 180. Okay, and this is going to be 8 pi over 18. Now, really, I should put degrees in there, but they're going to cancel anyway. That's the same thing as, what is that? Wow, 4 pi over 9. Sorry for my writing there. That is a 4 pi over 9. I gotta redo that. It's bothering me. This is 4 pi over 9. Okay? To go, and the second one, to go from 9 pi over 4 radians to degrees, well, I'm going to sort of do the same thing, but I got multiplied by a different form of 1. So I got 9 pi over 4. I want degrees, so I'm going to put 180 degrees in the top, pi in the bottom. These will drop. 180 over 4 is 45 degrees. And 9 times 45 is 360 plus 45. I believe it's 405 degrees. Okay? What are we at? Getting close to the end, guys. Okay, so this is just draw. Pi radians, pi over 2, negative pi over 4, and negative 3 pi over 2 on a coordinate axis. Okay, and the key to remember here is that 2 pi radians is equal to 360 degrees, or pi radians is 180 degrees. You can keep going from there. So yeah, what are you going to get for these? Pause the video, and when you're ready, restart it and see if we agree. Okay, so pi radians, that's 180 degrees, that is right there. Pi over 2 radians, that's 90 degrees, that is right there. Remember, guys, we always start at 0, which is straight, to the right here, and positive angles, no matter range of degrees, you rotate counterclockwise. Negative pi over 4, that is right here, right? That is negative pi over 4 radians. That's about 45 degrees. And negative 3 pi over 2, there's pi over 2, there's 2 pi over 2, there's negative 3 pi over 2. So right here is negative 3 pi over 2 radians, which is the same as negative 270 degrees, which is the same as 90 degrees if we're talking about coterminal angles. Okay, onwards. This one we will also skip. That's lesson 2. This is very similar to what you did before. It's special triangles, but now all these angles are in radians and not degrees. Okay? So see if you can fill in the special triangles themselves. See if you can compute all these sine, cosine, and tangent functions. And pause the video now, and then we'll see if we agree on numbers in a second. Okay, so first thing, special triangles. So this looks like the 45, 45, 90, and actually I'm going to write it a different way. I'm going to write it with radians. All right, so in degrees, these are kind of our quadrant 1 angles that are important, right? If we convert these to radians, this is pi over 6, right? Because 30 is equal to 180 over 6. So 180 degrees. If that's the same as pi radians, right? If 180 and pi are the same, well, 30 degrees, I'm not really drawing this very well, am I? 30 degrees is the same as pi over 6 radians. 45 degrees, that's the same as pi over 4 radians. And 60 degrees, that's the same as pi over 3 radians. Okay, so ideally, we want you guys thinking in terms of these and these sort of at the same level. But if you have to convert at first, that's no problem. Okay, so we'll fill these in. I'm going to fill them in without converting to degrees, but feel free to do whatever you're more comfortable with right now. Okay, let's get these special triangles. So I'm going to assume this is our 45, 45, 90. And you know what? I think I did it again. Let's make this. This is pi over 4. This is pi over 4, and this is 1 root 2. This, up top, this looks like 30, so that's pi over 6. That means this is 60, which is pi over 3. And this is going to go 1 root 3, 2. Okay, sine pi over 6. That's the same thing as sine 30, that's a half. Cosine pi over 6 is root 3 over 2. Tan of pi over 6 is 1 over root 3. Okay, another thing about tan, it's actually the same as sine over cosine. So if we look at, how does this come about? Well, 1/2 is sine, root 3 over 2 is cosine, 1/2 over root 3 over 2, the 2's drop, and you get 1 over root 3. Okay, sine pi over 4, so that's 1 over root 2, this is 1 over root 2, and this is 1. And these, I'm going to go to orange here, we could write as root 2 over 2. A lot of times, if you guys are going to take AP next year, you see that root 2 over 2 a lot. And let's see, sine pi over 3, so that's root 3 over 2. This is 1/2, and this is root 3. Okay, so hopefully those are numbers you're getting.